Let's talk about calculating IV flow rates. I think we have a term here that you have to know. Alright, they're going to call drops per minute GTT. I don't know how they came up with GTT, but that's drops per minute. And here's going to be your equation. Alright, your equation for the flow rate, which is going to be in drops per minute, that's what we'll be calculating, is the volume. It's the total amount to be infused. This is going to be in milliliters. Then we have a calibration, which is in drop factor per milliliter. And then it's going to be divided by the total time in minutes. Remember, it's not hours, it's minutes. What's what?
What is the GTT?
This is drops per minute.
What is over?
Minutes. This is drops per minute.
So is that an M?
Yes. Alright, so our shortened form for our equation is going to be F equals BC divided by T. That's all.
One for that.
What is it? Drop factor in drops per milliliter. Yeah, GTT per milliliter. In drops per milliliter.
Is it always in minutes?
The total time is always in minutes. Alright, here's our general equation for the flow rate. It's not going to be that easy. Sometimes we're going to have to calculate for time. They may not want to know the time to be infused. If they want to know the time, what's our equation going to be? BC over F. If they want to find volume, what is our equation going to be?
FT over C.
FT over C. So, depending on what, we can algebraically manipulate the equation in order to solve for one of these other factors. So we got time, we got volume. What if they wanted the calibration?
FT over B.
Now, just as a reminder, I'm going to put our general equation here. Everybody good with that? I gotta come up with a problem here. Everybody good? this problem here, we have, the order is going to be 1,000 milliliters of 5% dextrose in water to be infused in 8 hours. The drop factor of the infusion is set as calibrated as 20 drops per milliliter. And what is the flow rate in drops per minute? So what are we looking for? F, right? So we're looking for F. So if we're looking for F, it's going to be this equation right here, right? F equals VC over T. Now if we remember, T has to be time in minutes, right? Over here where our T is, this is in hours, right? So T equals 8 hours. Now we have to convert that. So how do we convert that to minutes?
60 minutes.
I'll just use dimensional analysis here. 1 hour is 60 minutes. That cancels. This equals 480 minutes. That's what we're going to use. All right, so that's our T. What is our V going to be? V equals 1,000 milliliters. So that's our V. And what else do we need here? We need a C. And our calibration is this right here, right? So C equals 20 drops per minute, per milliliter. All right, so let's solve this problem now. Using this equation. At this point here, all we really have to do is plug in and solve, right? Because we defined all of our variables, all we got to figure out what is F. So let's go like this. Our V is going to be what? 1,000 milliliters times our calibration, which is 20 drops per milliliter. And we're going to divide that by the total time in minutes, which is 480 minutes. Now there's our equation. Let's take a quick look at this. What's going to cancel? Well, we got milliliters here in our numerator. Over here we have milliliters in our denominator with our drops here. So this milliliter will cancel, this milliliter will cancel. What are we going to be left with? Drops per minute, right? And what is our flow rate? Drops per minute. So we're calculating it correctly. So if we multiply 1,000 times 20 and divide that by 480, what are we going to get?
41.6 repeated.
41.6 repeating drops per minute. Okay, now, we're not going to get 6/10 of a drop. And in this case, we could round up, so we're going to say it's approximately 42 drops per minute. We'll give them 4/10 of a drop there of extra medication here. I don't think it's going to hurt. Make sense? Milliliter.
No, it was something like that, 1 hour.
Hours and hours. All right, not a bad problem. All right, everybody good? See? What is VT? Where are you? Which one? This one?
VC.
That's volume times calibration. The calibration is in drops per milliliter. Does that make sense? All right, everybody good? Just no? Next problem. And this time, we're going to calculate the infusion time for an IV of 1,000 milliliters of this substance infusing at 50 milliliters per hour. Which equation are we going to use?
Time.
Yeah, we're looking for time this time, right? So time equals VC over F. Let's define our variables. The V equals what? 1,000 milliliters, right? And our F, the infusion time is going to be what? Yeah, the F is going to equal 50 milliliters per hour. Now this is different than the last one. They tightened it up into hours instead of minutes. What's our C going to be?
What's that? D5, what is that?
That's the medication. It's what
Oh.
it's called, D5LN. I honestly don't know what it stands for, but there's no calibration factor on this one, right? Since we don't have that, then our equation is simplified to just V over F. All right, if we don't have the C, we don't need it. Now, let's solve. This is going to equal 1,000 milliliters over 50 milliliters per hour. In this situation, we have milliliters in our numerator and milliliters in our denominator, so the milliliters cancel. We're going to be left with what? Hours, which is good because we're looking for time. So if we divide 1,000 by 50, what are we going to get? 20 hours. Does that make sense? So if they don't give us one variable, we can just knock that off.
Doesn't matter which one.
Well, if they gave us, I think they have to give us volume. They didn't have to give us the drops per milliliter. Yeah, we didn't need that. The key thing is when you get to this point, the units that you're looking for, everything should cancel out except for the units you're looking for. So that's how you know you got the equation set up correctly. Make sense? All right, everybody good on this problem? All right, let me do the next one. going to have to calculate the infusion time for an IV of 1,000 milliliters of this substance. It's going to have a calibration of 20 drops per minute, and the drop rate factor is 10 drops per milliliter. So what do we have to do first? Yeah, which equation are we going to use? Well, first we're going to have to calculate our drop factor, right? Yeah, because we need the drop factor. So let's go like this. Number one, say X ml over 20 drops, right? Okay. We got drops here, milliliters there. This is going to equal drops are going to cancel. What are we going to get? Yeah, this is going to equal 2 milliliters. And that's per minute, right? This is 1. 2, what are we going to do? Calculate the milliliters per hour. Does that make sense? So let's go like this. We're going to know the milliliters per hour. There's 60 minutes in 1 hour. We start out with 2 milliliters per minute. So our ratio is milliliters, milliliters, minutes, minutes. Is it a proper ratio? Let's move to solve. After we calculate that out, what cancels?